Hello everyone, we are now live. Today I'm going to be doing some particle branching using geometry nodes, simulation nodes, and all that cool stuff. You may have seen a video that went up, I think this week, showcasing a kind of particle branching effect, and I wanted to do a little showcase of that because people were interested. So this will be done from scratch. The previous setup I used some node groups to make the process a little bit easier, but it's fairly simple, so I'll just start it off right now. So the basic concept of it is that you have particles moving around semi-randomly, and every so often they duplicate, and after they duplicate and move around, they get trailed and then meshed, which it's pretty simple to do. So let's get the movement down. Let's get a simulation zone right here. We'll feed in just one particle into the mix. Let's go and turn on snapping because that's very good. Let's just go and organize everything just a little bit. Move this over to here. Snapping, there we go. So what we want to do is use a set position node and then just offset it by a certain amount. So in this case, I'm going to use a vector math node. Let me also assign that to a quick favorite because I forgot to do that in 4.2. No, a vector math node, my bad. So let's go, vector math. So what we want is to make it go a certain amount every single time. So in this case, we have 1 point and we're just having it move up. But I want that orientation to be randomized a bit. So let's actually a vector would be good. In this case, let's just have it face upwards, and then we'll add a random amount to it. So in this case, a random value node, let's set it to be -1, and then we can scale this by a bit to randomize how much it'll influence the main effect. So there we go. So here we'll see that it moves in one direction, which reminds me that I need to make this change per frame. So if we do this, we should see that it should be affecting it a bit more. But you may be noticing that this isn't looking too great. It's moving a bit too fast. So how do we make it so that it goes a set distance over time? Well, the good thing is that's fairly simple to do. We can use a normalize node to make sure it always goes a certain distance. In this case, it'll make it go 1 meter, no matter how much this adds to it. So in this case, it'll change basically only the direction. And then after that, we can scale this using a vector math node so that it will always move a set distance, in this case, 0.1. So here, if we take a look at this, it's moving around, doing all crazy stuff, and it's just doing that, which is really cool. Let's go and do this. So this is our movement. So movement. So now what we can do is randomize the duplication. So let's go and move this over by a little bit. Should I do that before or after? I think I'll do that. Yes, let's do that after the set position. That would be a bit better. So this part's pretty simple. We just want to duplicate elements. In this case, point is just fine. And we're going to split the branches just so that this is more convenient. So we have the main stream of geometry, and we'll join in the duplicates afterwards. So in this case, we have the main mesh with all the indices working just fine, and then we add in the duplicate ones with the indices also working just fine. In theory, well, let's see if it works okay. So in this case, we could either plug in a random value for the selection or the amount. In this case, we just want it to switch between 0 and 1. So I think in this case, I can use a random value because we could make it so that there are more than one duplicate. But in this case, I think it just switching between 0 and 1 is good enough. Let's go and plug in a randomization thing right there. So if we play this now, we should see, yep, it is splitting way too fast. That reminded me that we should probably have this be a random value because we can change the probability. So I'll plug that into the selection instead. I kind of forgot about that part. So now if we do this, it'll do that, and then we can see it starts duplicating, and then all that starts happening. Now this is a bit exponential, so you may want to put a failsafe after this. Which, yeah, just to go through all this thoroughly, let's go and do that. So this will be duplicate points. Duplicate points. There we go. And now I'll put in a failsafe, which in this case we'll use the domain size, so that if the point count becomes way too high, yeah, this is a point. This could be vertices, I should mention, but In this case, we're just using points because they're a bit easier to track in the viewport. So if the point count becomes too big, we'll switch the mesh to be nothing. So in this case, if the point count becomes greater than a certain amount, then it'll switch to be nothing. So this is our failsafe. There we go. Let's go and put that into a nice little frame right there. So this is the failsafe. So in this case, we want this to be like maybe 100,000. That's 10,000, 100,000. Because this is exponential, that's just something where it's like, hey, if you get to be too much, just call it, cancel it, you're good. Okay, now that we have that, we have our first part done. This is the section that deals with the movement. Now let's get the section with the trails done. Should I put this into a node group? That might actually be good. Let's have it ungrouped just so that it's a bit simpler for people to see. So, how do we trail this? Well, we can use a simulation zone. So, what you want to do is trail the particles. So for this part, we can use a join geometry node to join the particles into the system. So in this case, we'll see that these start getting trailed, which is pretty cool. So we can see that it starts doing that branching. So let's go and turn up the randomness of it. There we go, that's looking pretty cool. Still very much biased towards going up, which I could just have a vector rotate node, but with the Euler stuff, I'm still not sure if I want to do that. We'll look into different methods for that. And then after this, we should be able to change the points to curves, but with a little catch. So let's do points to curves. There we go. We should see that this starts freaking out, but we are getting curves. So what we need to do is store the index value before it gets fed into this system, so that we can plug it into the curve group ID. So let's go and do that. Let's go and store a named attribute, have it be an integer. This will be the index, which the index should be fine because all the new stuff gets joined in later on. So the indices of the main ones should be okay. Okay, so let's have this be ID1, I guess. I just don't want it to conflict with the Blender's internal ID attribute, but I don't think I can do that at the moment. So, named attribute, let's go and just copy that into here, make sure it's an integer, and then plug that into there, and rerun the system. Okay, we can see that that's working very well. Yeah, that's working very, very well. Okay, let's go and change the randomness to be a bit less. Again, I'm going to redo a bit of the branching technique because it's just a little bit, it could be better. It could be better. Okay, yeah, that's pretty good. So now we're getting the branching. So what if you want to make it so that the points don't stay infinitely long? Well, for that, you can use an age parameter to do that. So let me go and implement it. So let me go and move this over. I want ample space for all this to function. So let's do this, and I will label this section trail. I'm very happy that, trails. I'm very happy that this is so simple to set up. Before, it was very difficult to make trails with the curves before the points to curves node, but now it is fairly trivial. So let's store a named attribute on the points. This will be age. That will go up every single frame by 1. So in this case, we can add by 1, plug it in, and that should be good. Okay. There we go, and then we will make them delete if the age becomes too high. It is a little too frizzy. Yes, we will be fixing that. We're starting off with just the simplest version first, and then building up to the more complex ones. So in this case, once they... Yep, there we go. So now they will last for 15 frames and then get deleted. That works very well. No glitches so far, which I'm very happy about. So let's change the noise or the offset so that it'll carry on its previous offset, and then we mix between the old offset and the new one, which in this case, that should be fairly simple to do. So instead of just setting the position, we're going to store a kind of a velocity value. So velocity, and we're just going to plug in this to here. So now the offset is stored from the previous frame, and we can go and manipulate that later on. So let's go and put that into a frame. This will be movement. There we go. So now we can mix between the old velocity and the new velocity. So in this case, let's go and put this over to here. Now I want to mix them and not make more energy than there was previously. So I could mix them and then do the normalized thing again to set the distance just to make it a bit better. And yeah, that might actually be better. We'll go and test that out. So let's try it first with just mixing between the two. Now we should see that it's a lot more consistent. We get a lot more consistent variation with all of that. Let me go and just have... We could store an initial velocity and then change it over time, which may be better. So that we can say, oh, you're going up first, and then we just add to it randomly. And yeah, that would simplify things a bit. So let's just go and remove basically most of that. We'll do this, and then, wait, I want to keep the normalize and set that after the fact. So that it will always go 0.1 meters per time step, which could be cool. So let's go and do that. We can delete that. So the movement, we can just mix all that into there. Okay, we're seeing that we're getting something a little bit different, and we could go and bias the old velocity once again. Yeah, let's go and bias it a lot more. There we go, so now we're getting that. It still feels like it's a bit too much, so let me lower that a bit more. There we go, okay. There we go, that's looking pretty cool. I still feel like it's way too much, though. Why would that be? Again, maybe I should just vector rotate it, and that might be a bit better. There we go, that's looking pretty cool. Okay, let's go and extend the trail lifetime. So in this case, let's make it 150 frames. Let's go and run it again, and now we should see beautiful branching. 12 minutes, that's not bad time. There we go. Beautiful branching, and it's working very well, and we can see that it's becoming quite big, quite big. Let's go and edit the factor again, so that it'll mix between the two a bit better. Like, in theory, I could just add these, and that may be a bit better, so I may try that. Yeah, look at that. That's looking so cool. Okay, let's try just adding them and seeing if that's a better method of doing it. Because right now, that's way too much. So if we do 0.1, again, it's... Actually, the initial velocity is 1, and then it gets set to 0.1. Yeah, we'll see. We'll see how it works. So let's go with the new method. There we go. That's looking very, very cool. So there are multiple ways of making this happen. Like, I could just make the points be vertices and then extrude those so that we don't even need to do the trailing step. But I feel like this is just the simplest, maybe the simplest method. Because it's like, okay, you have your particles moving, and then you trail them. That's very conceptually simple. While when you have the edges, it's like, okay, which edges can be extruded, and then those are moving, okay, and then they can do that or that or that. This one just feels a little bit better, and it's a bit easier to trail because each curve is separated, which I think I should probably look into next. But I am going to try rotating the vector. So rotate vector, let's go and rotate it by this and see how that goes. Which this should affect it a bit more. If I do this, yeah, we can see that it does that, which is... Yeah, I'm not sure I'm the biggest fan of that one, even though it doesn't look too bad. Just becomes rather noisy over time. Which, speaking of time, I could have an age value for the particles so that I can manipulate some of the parameters later on. So as they get older, they can like slow down, or actually, yeah, that's a good idea. Could store, whoa. Okay, I thought they sped up a bit, but no, that it was just close to the camera. So now I could, let's turn these into easy to use node groups, which I think could be a good idea. So I'll probably change a few of these values. So instead of age, I'll make this trail age. So let's go and do this. Then maybe I can have a trail lifetime and all that. The ID should be fine, like I don't really need to change that. It could even be a capture attribute node, but this is just easier to deal with. But do I even need to make that a node group because it's so solid? Like it's a solid block that you don't really need to edit all too much. Yeah, I think that's good. Okay. So let's also add the age parameter to this one right here. Let's go and just connect this into there so that we have a nice block. I like blocks. Blocks are good. We just have that. It's just a nice unit that you can change pretty well. So let's go and duplicate just this part. Just instead of trail age, we'll go and just make it age. Let's go and copy that from there to there to there to there. Pretty good. So I don't want them to delete, because if they delete, the indices can become a bit weird, so I'm not going to delete the geometry. I'm just going to keep the points there, and they're only going to split, because if a branch ends, that's not quite the best. So this will be just age. So now that we have that age value, I can make the speed go up or down depending on how long the particle has existed for. But then again, I could have just done that with the frame range. I don't know, this is probably better. Or is it? Because I could just use the current frame to say, hey, speed up or slow down. But then again, if I do ever want to eliminate certain particles and fix that index issue, could be good. But we'll go and check that out later. Yeah, that's looking pretty cool. Okay, let's use a map range node, because now I think let's make it slow down between 0 and 150 frames. So I'll go from 0.1 to 0.01. And let's see how that affects everything. So they start out like that, and now we can see that the branches are getting smaller and smaller, looking more like a tree. And we can see that, I don't know, that's a very interesting looking tree. I think it's because since the scale goes down, the noise starts affecting it more, so we get something like that. I also want to just eliminate the age threshold for that, but it's probably fine. So here, let's just make it so that they exist for 500 frames, and now, as it develops, we can see that's looking quite a bit like a tree. Now, I could go and make these duplicate a bit more, but in there lies issues, potentially, as we can see here. Fortunately, the failsafe kicked in to the point where, like, it no longer grows, which is very, very good, because things could have gotten very, very bad. But let's make it so that, there can be 1 million particles. There we go, and yes, we got a few more frames. Now we have 1 million trailed points. So let's go and turn that down by a bit. I could also make it so that the amount of duplications slow down with the amount of particles in the scene. So I could use, say, the domain size to edit that. Let me also go and speed up the particle there. Now we get a much larger tree, and then the noise takes over time. So let's go and do that. More and more options to play around with. So let's just go and get the domain size, and then use a map range node to say, hey, if the particles go to like 10,000, reduce the probability of new ones spawning to be very, very, very low. So we'll set it to 0.2 to 0.1. So in this case, we'll see that they start off like that, and then they start slowing down dramatically. Now we have something like that, which is pretty cool. I do want to mesh these, so let's go and try meshing them. This will be rather slow, so let me go and put that into a frame right there. I think all that's pretty good. Let me go and put this into the blocks. So there we go. Sometimes it looks like cordyceps. Yeah, that's how you say it. Funny you should mention that, because I've used a modified version of this a long time ago to recreate the Last of Us intro, or at least the fungus growing pattern of the intro. So here, that kind of looks like a tree to me. Okay, let's go and use a curve curve to mesh node. There we go. The spellings are a pain. And now let's use a circle node. Curve circle. Oh, that hit. That hit hard. Okay, yep, that's a lot. So now we can take a look and see, oh, that's a lot of meshes doing their thing. Yeah, that's a bit much. So, and also we need to affect the radius over time, which I could do in the simulation part by dividing the radius by a certain amount as it goes along, or I could just do it with taking the age into account. So let's go and use a set radius, set curve radius. Yeah, that'll work. Uh-oh. Okay, let me go and rerun the sim, but make it so that, you know, the duplication ends, quite a bit earlier. So here we just have that. Yeah, that's a little more reasonable. It's still lagging just because it's still a lot of geometry. So let's go and use the age, then use map range to say, yeah, maybe when you get to frame 100, you get a lot smaller. Still feel like that's not quite good enough. I could also use a power node to make it possibly look a bit better. Because I think the radius should be a post effect rather than something that happens inside of the simulation. Let's set that to like 3. There we go. Now we're getting something that's a little bit more tree-like. Kind of exponential fall off right there. We can extend this to be even more, where... Actually, how long should they last? Well, I guess I can decide that, can't I? I can say, oh, the tree's like that, and then, wow, the tree's so big. So if you ever do bake the trail, which we could do, I could just bake the output right there so that it doesn't have to recalculate. There we go, that's looking pretty good. And also, I could make it so that trail isn't even needed, possibly. Actually, no, I can't. Because the curves split. Which, yeah, the curves split, so I can't use like a trim curve node to make it work as well as I want it to. Or wait, no, there's this handy thing called the trail age, which means that I can make it so that they start off at a certain radius, which, why is that inverted? There we go. So they'll start off like that, and as they get older, you know, all that stuff happens. So 50 frames, that is not good. But we can see that, okay, maybe I should have a main thickness using just the age, and then the trail age will determine how long it takes for it to get to that regular radius size. So there we go. How do you split a curve? Is it just multiple curves overlapping? In this case, the particles split. So if we take a look at this, we have particles that are splitting and doing their thing, and then they get turned, they get trailed and then turned into points to curves. So in this case, oh, the cache had a problem. So the splitting in this case is just a new curve begins while the old one stays there. So in this case here is the main curve, and then a split happens right there, and it works well. Okay, so let's go and use the trail age to multiply the radius so that we can make it look like it's growing instead of just appearing. There we go. So here, let's make it so that, is that good? Oh no, they're getting, let's make it so that 50 frames, it'll go from nothing to final radius. Which could look a little bit weird, but I think that's okay. And I think I need to turn down the split factor, because that's a bit much. So there we go. We can see that it's now growing. Like that. So, should I make it so that the amount of noise goes up, or maybe I'll just increase it right there. And also, you could have just a noise texture making that. Wow, that looks so good. Dang. Huh, that's cool. That's looking very good. Wow. What else should I do? Yeah, that looks like a tree to me. We could also, I should mention, we could also bias the branches with a little bit of like a gravity force. There we go. So here we can see them moving up. Do you think you can simulate crown shyness? I'm not entirely sure what that is, but I'm assuming like the branches try to stay away from each other. Is it like the kind of Voronoi pattern that you see in like big forests where certain types of trees get their own space partitioned? Like, look at that. That's pretty cool. Yes, okay. Since these are particles, I could potentially do that. The one caveat being, the only self-collisions that I can implement are based on the particles and not the trail. I could potentially make it so that the trail... No, that would cause a dependency loop. Let me think about that. I do also want to make the edge extrusion-based version of this, which is very simple to the point, very similar to the point one. You just need some extra data, which may actually be smaller at this point. Yeah, I think I might try to make another version of it. But yeah, I can... Yeah, let me try adding some self-collisions. So again, since this is basically a velocity-based system, I can go and implement that. Branches are a bit round. Yeah, that could be fixed. Like, you could do some post-displacement, which could be fairly expensive, but in terms of tree generators, expensive is the norm. And also, I'll go into this with the mesh extrusion version. You could swap it out with a repeat zone so that you don't need to wait for the timeline to go the entire way, but it would be a bit more expensive just because calculating all these points doing their thing can take a little while. Look at that. That is pretty cool. Okay, let's try just a very simple point avoidance method. So, let's see. What is the node again? Index of nearest. There we go. So we have that, so we can get the position of the nearest position. So evaluate that there. Let's get the position of that. There we go. So now if we subtract these two... speaking of particle self-collisions, I do want to get... I want to try implementing the KD tree a bit better, Ashley, because I feel like I'm close, but I just haven't had time to try to fully implement that. And I should also mention that the Blender devs are, when lists get implemented, they're looking into... one of the community developers is looking into... exposing or making a KD tree node, but, yeah, okay, wait, I want these to be a set distance, not just a void, which, this one, a void or attract? I think that one may be attract. Yeah, in animation nodes back in the day, I looked up a tutorial, oh, whoa. Yeah, that one is being attracted, which, oh, that looks so cool. It's making, like, DNA-like, stuff. Ooh, that is interesting. If I take out the normalize, then I can make it so that they go half the distance to each other, which should mean that they are almost... Oh, wait, I forgot. They, like, the normalization happens, which could screw it up just a little bit. So I could make this a post effect. So that they just get moved, and then... Yeah, well, that's very interesting. Okay, let me make it so that they avoid each other. So in this case, they are trying to get as far away from each other as possible. Which is cool, but, you know, maybe a little bit overplayed. Well, let me go and reduce that. So in terms of making them so that the actual groups don't intersect... I think that would have to be on a per tree basis, which I think that's what they do in real life. Because in here, like, I could set an ID value for all the main branches, and, like, whenever a split happens, there's a chance that the ID splits, so that it tries to avoid nearby IDs. But I'm not entirely sure. I am not entirely sure. Okay, let's save that for later. Now I'm going to go and move this. Let's label this tree sim. So we'll have pre-sim, and then I'm going to make a version that is the edges that extrude, and that probably won't need them to be sim-based. Okay, there we go. Let's go and duplicate this. So now we're going to chop out a majority of this and make a version that is based on extruded edges. But quite a bit of the math is the same. I'll also turn off the domain size part just to simplify it, and we can add that back in later. But the general concept is the same. The particles are moving, but we're going to make it so that there's a certain chance of the end particles to duplicate, or the edges to duplicate. Yeah, that makes sense. That totally makes sense. So step 1, we need to change the point to a vertice so that it can be extruded. In this case, we'll just do this. So, let me implement this correctly so that nothing can go wrong. So we want to extrude the mesh, in this case the vertices. And then we want to make it so that the only parts that can spawn, or that can be extruded, or in this case spawned, I think, is the top. So this will be spawn, and we don't want that on the selection, we want it to be on there so that everything else gets reset. And we want it so that the initial spawn value is checked. This is one of the reasons why I didn't really want to do this part specifically, but that's okay. And also, I should mention that we want the velocity to be behind this. So when the offset happens, it happens like this. Actually, wait. No, it has to be separate. Never mind, sorry everyone. That has to happen second. So the offset here will be 0. But then it happens there, and then we just need the spawn attribute to say, hey, only do the stuff on these ends. This is why I just wanted to do the particle-based method first, because this one takes a bit more thought and is a little less easy to think about. There we go. Let's go and put this into a frame. There we go. So now that should work, but I also need to make it so that the points will not duplicate. And, oh, also I need to make it so that this will only happen there. That's pretty good. Okay, so these will only duplicate it if the random value is true and if it is the spawn points. Okay, with all of this, the math should be sound. Let's go and give it a run. So in this case, yep, all that's good. I'm so happy that, well, why is that? Okay, there we go. I'm so glad that node wrangler functionality is kind of back. So now we can see it works. So it's just like the particle version, except now it's extruding the edges. So now I can change this mesh to a curve, and it could work, and then I can curve to mesh. All that good stuff is still working as intended. So, yeah. And in this version, I can make it so that it avoids the branches itself, because it's all in one contained system. Uh-oh. Oh, skip. Alright. Here we go. So now I can make it so that they do avoid the branches if they get too close, because again, the branches still exist. It will be more expensive, because you're constantly looking for, oh, am I close to tons of geometry, and it'll get more expensive the more trails that occur, but it should be okay. But there we go. This is extrude, yeah, extrude, spawn, selection. Yeah. Selection. There we go. So now let's go and put that into a frame. This will just be start info. Sorry if the keyboard clacking is too loud. But yeah, there we go. So that's that. And also, this could be a repeat zone instead of a simulation zone. Because of the way we set it up, we don't even need to put any attributes into the output. That's why I like named attributes. You just don't need to connect anything when you do stuff like this. So here, we just swapped that out, and now we can just do a few iterations. Now, of course, this will be hella slow. Oh, I think I might have crashed. Okay, no, we're good. Because with the repeat zone, it keeps iterating again and again and again and again. Maybe with the for each zone, maybe I can make it so that it only does it on the ends, but we'll see about that. Let's look at the timing as well. Oh, it's bad. It's really bad. Oh, actually, 40 milliseconds. That's not... Oh, okay. So this exposes another thing that I need to look into. Well, because we're using the repeat zone, the random value will be the same, because, again, it doesn't update every single iteration. So we could have just an iteration value in the repeat zone and then do all that, but it's fine. I could use the domain size for a random seed instead. Because, yeah, the vertices should be changing each and every time. Where's the other? Ah, right, that. So let's go and change that to use that as well. So there we go. Now when we play it, it's fine. Just the benefit of this is that we can see all the changes live. Go, that is pretty good. So we can do that, change the gravity, and all that cool stuff. In this case, let's disable the gravity. We can change the age stuff. So if you don't want to wait for the simulation, you could do that. Yeah. That's pretty good. Pretty good. But I do like the simulation-based method a bit better, just because you can see it happening. While here, you can change like how many simulations have happened, but you know, it doesn't quite feel as good as watching the growth happen over time. But it is an option. You can just go and do all of that. Now for tree generation, I wouldn't really recommend using this method, or at least 100% this method, because it's rather inefficient. Like, it keeps growing it as if it is, well, yeah, it's a simulation-based method, while there are faster methods that are just like, hey, make a curve, add some noise, avoid nearby stuff, and then, boom, you're done. But, you know, this one isn't bad. Maybe I could, yeah, I'll also demonstrate. So proximity, geometry proximity. I still need to look into the group IDs for all this, because I'm still not entirely sure how they work. I haven't tested them yet. But that probably could actually help with like the crown avoidance thing. So here we can get the offset to the other parts so that we can say, hey, if you're close, move away. Assuming... yeah, no, that should work. So let's go and scale this. So now if I plug this into... oh, it's lagging. Okay, I did a little bit of lag. Wait a minute. Why is it not doing anything? Hello? Points? That's odd. I thought it would affect the thing because points and all that cool stuff. Wait, what am I missing? So we have the previous edge geometry, which let's go and take a look at the, oh wait, repeat zone, I forgot. Wait, yeah, why did it just be like, oh, I'm not being affected whatsoever? That should not happen. I'm actually a little confused. What did I screw up? Distance, sample position, group ID? Huh. Yeah, wait, what? What did I do? That should look at the edges and then try to go close to them. Let's have this be a cube instead. So yeah, we can see there it tries going to 0, and here it attracts to the cube. So what did I mess up? Was just the edge? Oh no, wait, I know what happened. Yeah, it's looking at itself. So maybe in that case, the group ID could be useful. Or wait, the group ID does not exclude certain parts. This is why self-collisions are so annoying, I tell you. I could separate parts that are new, so that I'll have to look at other ones, potentially. Yeah, what about that? Splits the elements of the input geometry into groups that can be sampled individually. So, let's ignore that for now. So right here, the reason it doesn't work is because the points are looking at its own branch. So it's like, oh, where should I be? Oh, wait, I'm already at where I should be, so nothing happens. So how would I make it so that it always does not take into account the nearest section? I'm not sure if I can, like even the index of nearest in this case would only get the one in the previous part. Well, who knows, maybe the KD tree in the future can help with that. But yeah, that is the setup. Now, I do like the simulation node version better, even though like this one, the setup's not too big, it's just, it feels a bit more complicated than just, oh, make the particles move, which let me take out that part because, you know, I want it to be cleaner. Make the particles move, then trail the particles, then mesh the particles. All those are very deliberate sections. While the other one is, oh, we're kind of doing two steps at the same time. That could be a little annoying to do. There we go. Now in this case it does need the simulation zone so that the trails work as intended. But maybe, I don't know, maybe there's a repeat zone. Yeah, I probably could make a repeat zone that just feeds in the new geometry into there. Yeah, no, I could do that. I could make it so that a repeat zone does all of this, but I think it's fine. Assign a unique ID to each branch and compare it to the ID of the current element, then use a Boolean output to select branches not in the current group. I would need to think about that, but I think that probably maybe would work. Let's see, a unique ID to each branch. We already have that covered, where you just have, hey, whenever there's a new split, assign an ID to that and just carry it along. I think that would be better for this version, because the points already have an ID assigned to them that is consistent. That could be a thing. Then compare the ID of the current branch. I also need to look more into the sort elements node, because that could potentially be better. Wait a minute. Just thought of something, but it wouldn't work too well. Because what if, again, KD trees would probably be better for all of this, and I've even, in my kind of coding adventures, I've tried to edit the index of nearest, index, not invert, index of nearest node. I added in a kind of depth input so that you can say, hey, I want the first one, second one, or third nearest, which it did kind of work, even though it wasn't a great implementation. But again, a KD tree would be better because you would just have more information. Where was I with all this? But yeah, what if I made it so I would say, hey, for this particle, create a mesh that, like with the sort elements node, let me try to explain this better. With the sort elements node, which I think in the future would probably be like a sort list node, I could have it so that the distance to a certain vertice would sort the IDs so that you could get the first, second, and third nearest, but the downside being it would only be for one vertice in the geometry tree, which isn't great, and then the index gets sorted and all that. But it could be useful. I'll need to think about that. I will need to think about that. Yeah, because the question is, how do you make it so that each element will ignore its own branch but look at everything else? Because the group ID, maybe the group ID is the key. Again, I haven't researched it enough. But with my current understanding of it, it would be like, oh, wait a minute. Proximity, let's go and get that. It would be, okay, this, if the point and the branch both have the same ID, they will try to reference each other rather than everything else except that. Which makes sense, because if it were the other thing, it would cause like another, it would be like each part is like, okay, Whereas the other part, and it would be a very inefficient algorithm because it'll be like, okay, one point evaluates the whole tree, another point evaluates the tree again, and it keeps doing that again and again and again, instead of each point just searches its own group. So, yeah. But in this case, I think that's all good. So I think this is the end of the stream, or close to the end, because it seems to be pretty good. Let me also just go and make this a little bit easier to look at. Again, there's the repeat zone version, in this case using the extrude mesh one, and then there's the simulation version, which in my opinion is just easier to understand because it's like you could go in and say, oh, there are the points. The points are moving, they're spreading, they're duplicating, and then the trails, okay, here are the trails, and then you mesh said trails. So, I think that's better. And then if you want to make the tree look more realistic, you can put like a displacement map on all that, and all that cool stuff. Do you know Vex? Only a little bit. Only a little bit. Yeah, I think that's pretty good. I could make it so that whenever there's a split, it tries to... Yeah, I could try that out as well. Like, whenever there's a split, I could make it so that the velocity does something very weird. Oh yeah, let me try that. It's kind of like one of the last things to do. So in this case, it's like, oh, when a split happens, what are you gonna do? You'll have a new initial velocity of -1. Let's try that out. That's a horrible idea. Or is it? Did I actually cook a little bit? Like, that looks like an alien tree. Here, let's try it the kind of opposite way. So now when they split, they go straight up. That could be something, potentially. Let's go and try this out. Let's also negate all gravity effects. So here... That was not a good idea. That was way too powerful. I think a mixed node would probably be better in this case. Let me just try out some different methods. But here we can see they just go up. So yeah, let's go and try that out. So here, let's make a better method of dealing with this. So instead of scaling it and being like, oh, what values are better? We will just normalize the velocity and the random offset, mix them, normalize them again. So in this case, we'll do a mix node so that we can just determine the influence with one value and call it a day. So here, we can just plug this into the normalize. So they get normalized, added, or mixed in this case. You know, it's kind of like adding, but you add and divide, all that cool stuff. And then you do that. So now this should be a lot easier to manipulate. So now I can just go and slide this value, and then we get something a lot easier to deal with. There we go. And now we can also go and duplicate this part, and then have it so that when there's a split in the branch, it goes a little bit more wacky, where it's not just, oh, we're going to reset this to be a certain value. It's just, okay, the branching, it'll take off in another direction, but it's still somewhat in the correct vein. In this case, there we go. Now we get something that looks fairly interesting. And also, we can bias we can add in that kind of gravity effect. This one is just better because it's like, oh, I don't care what the distance of the velocity or the random value is, we're just going to go and do stuff. So here, again, we have something like that. Let's go and change it again. I should probably go and implement this into the edge extrusion version, because I think we may be able to see the changes a bit better on that side. Let's also go and change the radius over here. In this case, let's make it like 0.5. Okay, I'm going to go and copy this section and bring it over to the other one. Also in 4.2, I'm not sure, but in the earlier stream today, I think I copied nodes from one blend file into another, which wasn't possible, if I'm correct, in previous versions. Let's go and delete, 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 and we want to keep you. So let's go and just swap out the scene time input with that. Because we need that value to update every single iteration, but we don't have an iteration loop input. There we go, and we could go and change that. There we go. So now if we take a look at this guy right here, we can now see, there we go, see that's better. We now have all that happening. So now we can see when it changes, it's like that, and then yeah, okay. Yeah, that feels a bit better because you can just see changes in real time. So yeah, both versions are valid for different reasons. But in this one, you know, it might be better to just test out some stuff. Let's see. Maybe if they start going down after a certain time, that can be done. Because I do have that... Oh, wait a minute. I don't need that. I can just plug in the age value. I am smart. Because it's like, oh, how do we get a random seed per frame? Wait, I have a value for that. And it works. There we go. Yeah, actually, maybe the edge version is better, potentially. It's just heavier because it all happens at once. But then again, I could swap this out for a simulation zone and it would work just fine. But yeah, that's something to consider. So you could have either the all grows in one frame option, or you can have the simulation-based version. So yeah, let's go and use that age parameter. Thank you for suggesting that. So here, I'll make, I want a vector math multiply. Vector math, there we go. So this will affect the z-axis. So it'll start going up, and then over time, it'll go down. But as we can see here, it looks a bit more like a, I guess, a weeping willow. Maybe. Oh, let's also change this to be, yeah, so if it gets to be too big. Yeah, we're just changing the failsafe. So now, what was it? Oh, right, I wanted to go and do that. Okay, so just a little bit, and then it becomes too much, and then the failsafe kicks in. There we go. That's looking pretty cool. So now I can change that up. Let me also change that to smoother step. So now we can have it so that the branching goes up, and then it goes down. And let's also increase the effectiveness of the other stuff, and then turn that part down a bit. So now it's like, oh, the tree is growing. It's going so well. Here, let me add down a bit more. And then over time, it's like, oh no, I am now depressed. Yeah, that could work. Though I feel like it overpowers the noise way too much. Which I could add in a separate mix for this one, which may actually be a good idea. Which, it is not lost on me that I accidentally made a metaphor. The age goes up and you get depressed. So, I can make this happen where, okay, I'll mix between nothing and then that happens. Or I can make it just so that the mix value goes up over time. So in this case, I can have this be -1. That's a sad metaphor. Though not always true, from what I've seen. Here we go. So that's one way that you can do it, and then you can just say, oh, go down, go up, go to the side. And this could be a random value. That's something I should do. Like, I should make it so that there is a random value per branch, so that I can make each individual branch go and do... And yes, I can do that. I can just go and store the index of the duplicate elements, and that should work as intended. So if I just store named attribute here, every time there's a split, it will give it an ID that I can then reference after the fact. So here, let's just make this ID1, like the previous one, ID1. So now, if I plug in an ID to this, I can bias each branch by said value. So yeah, let's have that so that I can change the seed. So now, each one of these, as time goes on, will mix between all of them just having a regular random value, and now, as we can see here, each one just goes in is biased towards a certain direction the entire time. Nice. So if we do this from the get-go, we can see that, yeah, we can just have these move in pseudo-random values. So there, that's it normally, and then it keeps going, keeps branching. And actually, let me try something else that could be cool. Let's go and use an add node so that we can see this effect over time. So over 50 cycles, like, that's actually pretty interesting. But maybe I should swap it so that it'll start off split. So here it'll be like, wait a minute. Yeah, there we go. So we can see more splits happening over time. So start off with just the big splits, and then more splits happen as time goes on, which is pretty cool. So again, it looks like the tree is assembling from just random fibers, and then just, and then boom. What if I added physics to this? Maybe that's a bad idea, but that could be interesting. But that's probably, yeah, that would be a post effect. I generate the tree, and then with any movements that happen, I make it so that a wobble happens, and then all those get stacked. Which means, yeah, no, I could add in a parent ID and a loop ID, so yeah, that could be done. 100%. That could be done. But yeah, we're getting close to an hour, so I think I'll call it right about here. But yeah, this was a cool experiment. Lots of cool stuff can happen with just some math. Okay, why is it all leaning to one side? Oh wait, that's just how gravity works in this scenario. So it starts off like that, and then it does that. Okay, yeah, that's cool. I can clamp the factor. So here I can make it an S-curve. That's really funny. So it goes down, then it goes up. If I go and reverse that, it goes really high up and then down. Looks like a firework. But yeah, that is what you can do. So that's a kind of tree generator. Is it great? I'm not sure, because you kind of have less control over all of it. And also, I should mention that I could... Oh wait, yeah, no, let's go and do that. Because right now, the branches are kind of linear in their kind of creation. They're just like, oh, a branch happens, and they're all kind of equidistant. They don't need to be. I could make it so that there's different branch length using that ID value. But I could also make it so that extrusions just happen randomly. So, in this case, I can make it so that... Oh wait, I would need... Yeah, I do need that domain size so that I could get a per iteration value. No worries. Domain size, point count, yeah, let's just go and plug that into the seed, or it could be the ID. Yeah, let's plug it into the ID. So now, this will make it so that... Wait a minute. It's that and that. Okay, now there is a random... Oh, wait, no, I do need that right there. Okay. Shoot, accidentally deleted the other stuff. Okay. Let's lower this value. Actually, no, let's leave that one be, and I'll just have a separate value. Okay. This will be another kind of post effect. So this will be, hey... There is an option, and oh, yep, that caused almost a crash because it was way too frequent. Let's change this to 0.05, 0.05. So this will make it so that every single point on the branch has the opportunity to just freely create a new branch. In this case, it should look a bit more randomized, even though, unfortunately, just with the way the math works, it'll bias towards... I wanted it to appear more there than, there. Maybe I just need to reduce this even more. Oh, wait. There... Okay, let's forget about that one. Doesn't seem to be working the way I wanted. I wanted to make it so that... there would be a random chance that a little branch would spawn in after the fact, which is possible. I've done it before. It seems like in the setup I didn't quite set it up correctly. I could make it so that there's either a random... Yeah, no. Okay. But the random branching just overloads the system way too fast. Because there's too high of a chance of splitting actually happening. Wait, let me try that one more time. So this will be or... We want another one of you, domain size, so that every time a repeat zone happens, there's a new chance of a duplication happening. Yeah, let's try it one more time. So... Yeah, we can see how fast it goes haywire. But why is it... I should also probably plug that into there, so that's a bit more efficient. Because this would ignore the spawn parameter that I set for it. Why is it not... Too many iterations? Is that it? Anyway, okay, let's forget about that part. Let's forget about it for now. Yeah, there, that just makes it a little more efficient so that the ID doesn't get set. Oh, wait a minute. Oh, no, it's fine. Yeah. And the amount is just... What was the input there? Wait, why was there an input for that? That was not supposed to happen. Maybe that made it the... Wait a minute. How long was it? What was that connected to? What was that connected? It's not connected to anything. That's weird. Or, okay, maybe I deleted something and then that caused it to happen. No, okay, that wasn't the cause of it being... Was it just that? No, I would have seen that link. Okay, let's forget about that for the last time. We're over an hour now, so I should go and wrap up the stream. Pop that out. There we go. Turn that up. So yeah, that's one way of making a tree generator. In this case, I think this is more like a savanna tree or a bonsai tree. But there are more ways of doing it than this. This one is just, you know, could either be a point-based method or an edge extrusion method, which could be cool. Alright, and that's the effect. I hope you all have enjoyed. I hope this was understandable. It's not the biggest node setup, but it is a little bit dense and a little bit complicated. Like, it's funny that the one that is technically bigger is more understandable just because it's units, like move particles, rail particles, mesh particles, instead of them all being one gigantic unit. Okay, yep. Let's go and just show both of them so that we can see both versions. Yeah, and I could probably change the settings on that. I do like this one just because you can experiment a bit faster and not need to replay it over and over and over again to make it, worse. Or to see the results, that's what I mean. Right, let me read the chat. Okay, everything seems to be good. Oh, someone asked something. How did you turn so good at geonodes? Mainly from playing around with them and then looking at the documentation when I could not figure it out. And then also looking at Houdini stuff to see how they do that, because a surprising amount of the math transfers over. So if you see how the pros do it, you can incorporate that into your workflows. But yeah, geometry nodes are pretty cool. Alright, thank you all for watching. I will see you next time, and have a good one. See ya.